Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers Surds. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Okay, we're given an equation for y. Y equals 5 root x divided by 2, and we need to circle the expression for y squared. So y squared is, well, it's what I had a minute ago, squared. And when I square a bracket like that, everything inside the bracket is going to get squared. So it's going to be 5 squared root x squared over 2 squared. 5 squared is 25, root x squared is x, and 2 squared is 4. So it's 25x over 4. It's that one. Okay, the square of x is 7. Circle the value for x cubed. So the square of x is 7. That means that x squared is equal to 7. So x is going to be the root of 7. So what then is x cubed? Well, x cubed is going to be that root 7 cubed then, isn't it? And cubing something means timesing it by itself 3 times. So another way of thinking about this is it's root 7 times root 7 times root 7. But if you think about it, root 7 times root 7 is 7. So it's going to be 7 root 7. It's that one there. Okay, time for a little bit of fun with surds. I've got quite a horrendous looking sum here. 26 over root 2 minus 12 over root 18 plus 2 root 50. And I need to somehow rearrange this so it's in the form of a root 2, where a is an integer. Okay, so how are we going to proceed? Well, I've kind of spotted that 2 times 18 is 36, which is a square number. So by putting those first 2 fractions, making them I'll put them over one denominator, they should simplify. So let's try that. So I've got root 2 on the bottom of that one and root 18. So I'm going to put my common denominator as root 2 root 18. So you can see that this root 2 goes into root 2 root 18 times. So if I multiply 26 by root 18, that kind of works. I've got a minus sign there. And the same, I've got 12 over root 18. So root 18 goes into root 2 root 18 root 2 times. So that's going to be 12 root 2 on the top. I've still got that 2 root 50 I haven't done anything with yet. So I'm just going to leave it there. Okay, we spotted earlier that 2 times 18 was 36. So the idea was to make that root 36 on the bottom. Now, root 18, 18 is 9 times 2. So I'm going to rewrite that as 26 root 9 times 2. Just going to leave the 12 root 2 for now. And I've still got this 2 root 50 on the end that I haven't done anything with yet. What can I do with that? Well, 50 is 25 times 2. So let's change that to 25 times 2. Okay, now what can we do? Well, our denominator, root 36, is going to simplify down to 6 because the square root of 36 is 6. Now, breaking up this root 9 times 2, the square root of 9 is 3, and the square root of 2 is just the square root of 2, but I can bring the 9 out then, can't I? So that's going to give me 3 lots of 26. 3 lots of 26 is 26, 52, 72, 78. So 78 root 2 minus 12 root 2 plus, we can do something similar with this 25. I can break root of 25 times 2 into the root of 25 times the root of 2. The root of 25 is 5, so 2 times 5 is 10, so that becomes 10 root 2 there. Okay, now this is working out nicely. So 78 root 2 minus 12 root 2. Well, if you've got 78 of something, you take away 12 of that something, that same something, it's going to leave you with 78 take away 12, which is 66. So I'm going to get 66 root 2 over 6 plus 10 root 2. So then I can divide my 6 into my 66, leaving 11. So that's going to give me 11 root 2 plus 10 root 2, which altogether is 21 root 2. Okay, so it's in the form a root 2 where a is an integer, so our integer is 21. So 21 root 2 is the solution. 27. Write root 12 plus 15 over root 3 in the form a root b, where a and b are prime numbers. Okay, so let's see if we can rationalize that second part of the fraction first. 15 over root 3 multiplying top and bottom by root 3. It's going to give me root 3 times root 3 is 3. 15 root 3 over 3, like that. Okay. Now you can see that I can divide the 3 now into the 15, leaving me with 5. So that is equivalent to 5 root 3. Now my root 12 part, I can rewrite root 12 as 4 times 3, root of 4 times 3, and then I can break that up into two separate fractions, or two separate surds. Root 4 times root 3. Root 4 is 2, so that leaves me 2 root 3. So my original sum of root 12 plus 15 over root 3 is the same thing as root 12, which is 2 root 3 plus 5 root 3, which gives me 2 root 3 plus 5 root 3 is 7 root 3. So my answer is 7 root 3. So a and b are both prime numbers. So that's all good, all done. 19a, work out the value of root 2 to the power of 4. Well, root 2 is same as 2 to the power of a half. So I've got 2 to the power of half raised to the power of 4. Now when I've got an index of an index like that, we multiply the indices together. So it's 2 to the power of half times 4, which is 2 to the power of 2, which works out to be 4. For 19b, expand and simplify root 2 plus 3 all squared. So root 2 plus 3 all squared is going to be these two brackets multiplied together. Now use first outside, inside, last, or whichever way you remember how to multiply out double brackets. I'm going to get root 2 times root 2 plus 3 root 2 plus 3 root 2 plus 3 squared, which is 9. Root 2 times root 2 is 2. wrote 3 there. 3 root 2 plus 3 root 2 is 6 root 2 plus 9. So 2 plus 9 is 11. So it's going to be 11 plus 6 root 2 is our solution. Question 20. Work out the value of 9 to the power of minus 1/2. Now, I would treat these as separate operations. So you've got a negative index there, and you've got a fractional index there. And I would treat those as two separate steps. So 9 to the power of negative 1/2. Let's deal with a negative sign first. Negative index means 1 over the same thing to a positive index. So that would be 1 over 9 to the power of 1/2. Fractional indices mean the root of, in this case the square root of. So I'm going to take the square root of 9, and the square root of 9 is 3. So our answer is 1/3. Question 23. Work out the value of 5 over root 3 minus the square root of 6 3/4. Give your answer in the form k root 3. That's not very nice, is it? Okay, let's have a look at the first part of the expression first. 5. I'm going to break it down and do it in 2 parts and then subtract at the end, I think. Otherwise it's going to be a bit horrid. So 5 over root 3 part to start with. Now, if I multiply top and bottom by root 3, I get rid of the surd as part of my denominator. It's not very nice. So that's going to give me root 3 times root 3 on the bottom is just 3. And then I'm going to have 5 root 3 on the top, which is 5/3 of root 3. That's already in the form of root 3, which is handy. Now the second part, the square root of 6 3/4. Now 6 3/4 as a top-heavy fraction is going to be 6 fours are 24 plus 3 is 27. It's going to be 27 over 4, all square rooted. Oh, actually that's not so bad at all, is it? Because the square root of 4 is 2. That leaves me with root 27 on the top. Now 27 is made up of 9 times 3. So I can break that up as 2 different surd fractions, and the square root of 9 is 3. So I can rewrite that as 3 root 3 over 2. Okay, so then our original expression, 5 over root 3 minus the square root of 6 3/4, is going to be the same thing as 5/3 of root 3 subtract 3/2 of root 3. So we need to now work out what 5/3 minus 3/2 is. So 5/3 minus 3/2 lots of root 3. Common denominator would be 6. So that would be equal to 3 goes into 6 twice. That would be 10/6 minus 2 goes into 6 3 times. 10/6 minus 9/6, which is 1/6 of root 3. So that is in the form k root 3, where k is 1/6. A little bit horrible, but we got there. Alright, question 17a. We've got a laws of indices question. Work out the value of 8 to the minus 2. So whenever you've got negative indices, you can treat that as a whole separate step actually. So the minus sign is one operation and the 2 is another operation. So whenever you've got a minus negative index, it means 1 over that same positive power. So 8 to the minus 2 is the same thing as 1 over 8 squared. And I know that 1 over 8 squared is 1 over 64, so that's my answer there. Question 17b, solve 4 to the power of x is 8 to the power of 2/3. Okay. Let's try and make the bases the same for both these numbers. 4 is the same thing as 2 squared. So 2 squared to the power of x is equal to 8. Now 8 is 2 cubed. So 2 cubed to the power of 2/3. Okay, so when you've got an index and an index like that, you multiply them together. So that's the same thing as 2 to the power of 2x is equal to 2 to the power of, what's 3 times 2/3? That's just 2, isn't it? So 2 to the 2x is equal to 2 to the 2. So then equating our indices, because the bases are the same. These two bases are the same, look, they're identical. So it means I can equate the indices. So 2x must be equal to 2. So x is equal to 1. 17c, simplify the root of 3 to the 0 times 3 to the 1 plus 3 to the 2. Okay. So what we've got here then, well, 3 to the 0, anything raised to the power of 0 is 1. So I've got 1 times 3 to the 1 is just 3, plus 3 squared. 3 squared is 9. So I've got 1 times 3 plus 9. 3 plus 9 is 12. 12 times 1 is 12. So that's equal to root 12. Now 12 is equal to 4 times 3. So I can break that up into root 4, root 3, and the root of 4 is 2. So that's 2 root 3. So there we go, 2 root 3. Question 24a, work out the square root of 12 1/4 as an improper fraction. Okay, let's start off by expressing 12 1/4 as an improper fraction to start with. 12 times 4 is 48 plus 1 is 49, so that's 49 over 4, 49 quarters. Now luckily both of those are square numbers, so I can easily square root them. So 49 square rooted is 7, and 4 square rooted is 2, so it's 7 halves. That is an improper fraction, so I can move on. Work out the cube root of 16 as a power of 2. Okay, well, the cube root of 16, what is 16 as a power of 2? 2, 4, 8, 16, that's 2 to the power of 4, isn't it? So I can rewrite that as the cube root of 2 to the power of 4. Okay, which is the same thing as 2 to the power of 4/3. So that's my answer, 2 to the power of 4/3. Question 28. Simplify the square root of 80 plus the square root of 2 2/9. Give your answer in the form of a root 5 over b, where a and b are integers. Fun. Okay, so root 80. Now, if I take 5 out of 80, 80 is 5 times 16, isn't it? So root 80 is the same thing as root 16 times 5. And I've got plus 2 2/9. So that's a mixed number, isn't it? What's that as a top-heavy fraction? 2 times 9 is 18, plus 2 is 20. So that is the same thing as 20 over 9, all square rooted. Okay. So that first one, root 16 times 5, I can break that up into two different roots. The root of 16 times the root of 5. The root of 16 is 4, so that is 4 root 5. And on the other side, I can split that up into two roots. I can say that is the root of 20 divided by the root of 9. So that is the root of 20. The root of 9 is 3, isn't it? So it's that. So I've got root 20 over 3. Is that helping me? Okay, now 20 I can make to be 4 times 5, can't I? So if I leave that one for now, 4 root 5 plus the root of 4 times 5 instead of root 20. Then I can break that up into two separate square roots, and the square root of 4 is 2. So that's going to leave me with 4 root 5 plus 2 root 5 over 3. Okay, so we're almost there. So what can we do about this fraction on the left? If I want to put this over a common denominator, if I take 4, if I multiply top and bottom by 3, it's 4 over 1 at the moment. So if I multiply it by 3, then I'm going to get 12 root 5 over 3. So that is equal to 12 root 5 over 3 plus 2 root 5 over 3. So now I've got two fractions with the same denominator. So I simply add the numerators together. So 12 root 5 over 3 plus 2 root 5 over 3 is going to be 14 root 5 over 3. So it's in the form of a root 5 over b now, isn't it? Where a is 14 and b is 3. Now a bit similar to the problem with algebraic fractions. Here we've got surd fractions. We're going to have to come up with a common denominator to work out what's going on here. So if we made the common denominator, well, let's try and rationalize our denominators first and see what we've got. So I'm going to get rid of the surd parts of each of these fractions and then reassess, I think. Let's get rid of the surd. So 2 root 6 over root 5. I can rationalize these denominators by multiplying top and bottom by root 5. And I'm going to be subtracting root 3 over root 10. And again, I can get rid of the irrational part by multiplying top and bottom by root 10. Okay, so let's do that and see what we get. So obviously on the bottom, root 5 times root 5 is 5. That's why we're doing it. And on the top, I'm going to have 2 root 6 times root 5, which is the same thing as 2 root 30. And I'm subtracting. So root 10 times root 10 gives me 10 as my denominator. And on the top, I'm going to have root 3 times root 10, again, which is root 30. Okay, so now I've got 2 root 30 over 5 minus 30 over 10, root 30 over 10. Okay, so if I double up that first one, if I times top and bottom by 2, it should give me a denominator of tenths then, shouldn't it? So that's going to give me 4 root 30 over 10 minus root 30 over 10. Okay, so now I can put them over a common denominator of 10 then, can't I? Because they've both got a denominator of 10. And then to do that, I just need to subtract the numerators. So 4 root 30 minus root 30 over 10. So what's 4 root 30 minus root 30? Well, you can treat these a little bit like you would with x's. If I had 4x take away x, I would get 3x. So it's the same thing here, isn't it? If I've got 4 root 30 take away root 30, it's going to give me 3 root 30 over 10. Okay? So I've done it then, haven't I? So 3 root 30 over 10. That seems to work. C and D are both whole numbers. And it's a fraction over 10. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.